going to be putting together a big block Chevy 496. It's actually 498. It's 70 over on the bore, so it's a 4.320 bore. We're going to put a 4 1/4 crank in it, and I'm going to show you just a quick way to assemble a street strip engine here. It's nothing out of the ordinary, but it's pretty cool. It's really neat old vintage parts. The block and heads are old school. It's actually an LS6 engine that's going in a 71 454 Corvette LS6 tribute car. And here we go. We're going to bring this old 48-year-old LS6 engine back to life. It's going to be reborn right now. And just like that, an LS6, 48-year-old LS6 is reborn. How long it'll live, no one really knows for sure. You gotta have faith, right? Just like that. Bring her back to life. Ready to check the main cap clearance, main bearing clearance. I don't know my machinist this time around. Hopefully he has already checked this, but before I put it together, I always like to use some of this plastic gauge. I know it's not the most accurate way, but it'll tell me if something's way off, too tight or too loose, and keep the engine from blowing up on the dyno. I had this align board up at Little Falls. I've used those guys before, but I don't really... the caps came off from a different engine. They didn't match this block, so just want to make sure everything is up to snuff. And I'll check the rod bearing clearance too, just to double check, make sure that they sent me the right bearings and stuff. Plastic gauge is a tiny little piece of plastic that when I torque down the caps to specs, it'll squish that, and then we'll measure it with this package that it came in, and it'll tell us approximately how much bearing clearance we have there. And then we take the crank all the way back out, clean it off, and put the assembly lube on and put it all back together and torque it down once again. Okay, just about ready to put on that last main cap and then take them all back off and check the plastic gauge. Just wanted to point out one thing. Like I say, I hope, and I'm pretty sure that the machinist checked all this with a micrometer, which is micrometer or whatever, that a far more accurate way to check this, you know, but I always just feel better knowing that when I put it together it's not too tight or too loose. But I wanted to point out one thing. I don't know if you can see. It looks like, see, these caps didn't belong on this block. They didn't come with it. The block wasn't born with these caps. So I see these marks here. I don't know if you can see that or not. That's an indication that they've tightened up that. The caps are actually a light press fit into, I don't know if you can see, yeah, of course you can see. that groove right there, so they fit in between there in kind of a loose press fit. And there's been some adjusting. It looks like they kind of knew what they were doing when they line bored it, so hopefully everything will check out good. I'll put that last cap on and pull them back off and we'll check it. Oh, one more thing. I wanted to show that I did spring. I had a set of 2-bolt main ARP main bolts. I have those in there. Those are the ones that count anyway. You know, I've never been real fussy about the main bolts. The rod bolts are really critical. You know, I have ARP 2000 rod bolts, so the strongest bolts known to man, as Big Black Sean would say. But I thought we're going to make pretty good power with this engine, I hope. And I thought I'd use those ARP, the 2-bolt main bolts, anyway on the centers. The outsides are not really, they're just for bragging rights, you know. Especially, you know, on a 400 horsepower engine, they're not even necessary. But this thing, I don't know, I hate to make predictions, but we're going to make pretty good power, so I use the good bolts. I'm supposed to use a dead blow hammer. I just use a hammer handle and kind of tap them. And there you go. Usually go like 100 pounds on the mains and like 75 on the rods. And start in the middle and you work your way out. After torquing them down, it leaves a nice little pink mark. And you take your package that it came in here. I can do this. You measure it. And it looks good. It looks like they knew what they were doing. It's between 2 and 3 thousandths. Like I say, the mains aren't really that fussy, but the rods are super fussy, and you never want it too tight. You know, I'm from the school where, especially on the rods, I like to run them just a little loose on a high RPM application. Always better too loose than too tight. Never good to be too tight. But they're right in there, you know, somewhere between 2 and 3 thou. This middle one is a little tight, but that's usually what happens when you line board. A good line bore machinist will get them all the same exactly, but what the line boring machine likes to do is get the outer ones get sloppy right away. The inner ones stay tight, so you gotta know what you're doing when you're on that thing. It looks like they did a pretty nice job. Everything, they're all pretty much the same, and they're all from front to back too. They're even. You know, you never want to have that. That means your cap is tipped if they're uneven. And like I say, it looks like he made that adjustment for the press fit. You know, that keeps them from going side to side. It's really important that they're locked in there nice and snug before you start the line boring process. So okay, I've gone over everything twice. 100, 110 pounds. Like I say, you know, we're not building the... Okay, I'll spill the beans. It's probably going to be about a 700 horsepower engine. I don't know. Depends on how good the guy does with the heads. I'm hoping for better, but I hope it's not worse. But it's about a 700 horsepower engine, so that's why I still have these cast caps on here. It's just not going to be that fussy, you know. And don't let anybody tell you that assembling this in the bottom end on a Chevy 454 is rocket science, because it's not. If you can put together a doggone farm-out tractor engine, it's basic stuff. You can pretty much put together a 454, you know, a 600 or 700 horsepower engine. It's not that big of a deal. I do have a 4340 forged crank, and you can see it moves. You don't want to turn it too much because you don't want to wear off all your assembly lube. But of course, you know, you're going to have to turn it when you're degreeing the crank and when you're installing the rods and stuff. But I probably spent too much time on this crank installation, but like I say, the caps weren't original to the block, so I would just want to make sure that the line boring process got done properly, and it looks like it did. So everything, make sure you got your main seal in, make sure it's put in properly and matches up good, because that's a big problem if you get it all together with two-piece main. You know, I cock it a little bit so it's not halvesies, halvesies. You know, I cock the seal. I don't know if that's necessary. I used to put them together, you know, just made it up like that, and I never had any problems. You know, if you got a two-piece seal and a two-piece crank and a two-piece block, you know, they make an adapter kit to put the two-piece crank in a one-piece block, and that's where you run into trouble with your rear main seal leaking. But I've never really had one leak on this little Gen 4 stuff. So make sure you don't forget it though, and make sure it's in there right, or you're going to tear everything all back apart. Yeah, and you know, some people say I should have gloves on, you know, because my acid will touch the journals or something, but it's never been a problem for me. I mean, we're not building a NASCAR engine here, we're just building basically a pretty healthy street engine that's going to go on the drag strip a little bit, or a lot, but it's cool old stuff. And I caught. This is a stroker crank. It's 4.25 4340 crank. So before I sent it up to the machine shop, I clearanced a bunch of areas. You know, that's got that notch in there from the factory, but I made that notch deeper for the rod bolts. And there are some areas where the counterbalancers spin too that have been, it's hard to show you, but I did all that clearancing before I even brought it up. And you should have probably, you know, 50-60 thousandths clearance between everything that swings. It wasn't real necessary on a 4.25 crank, but if you use a 4 3/8 crank, like I did in my other block, you know, that was a dart block, so it came clearance. But if you're using a 4 3/8 crank in one of these original blocks, you're going to have to do some clearancing. The shot of the area, it's on the bottom of the cylinder is where it comes closest with H-beam rods. You know, if you use an aluminum rod too, you really got to clearance, because those things are huge. But this is just a regular steel H-beam rod with a 4.25 crank, and that's the area you got to be careful not to get too crazy with it. But there's a lot of little areas that come close. You just got to lay the crank in there and mock everything up, and get your grinder and go to town before it goes. Okay, let's put some pistons in. These are 70 over, the block is bored. I don't know, these are some kind of Icon pistons or something. This is a budget build. Nothing fancy, just kind of I bought a complete rotating assembly, balanced. They are forged pistons, of course. They're 24.5 cc dome, I think. So with a 118 chamber, you know, it might wind up being 114, 116, depending on what head gasket I use. Be around 11 to 1. And pump gas pistons, you know, small domes. The rings are nothing special either. They're just some Hastings. You know, I put file fit rings in my other one. And Big Block City ground them extra in case I ever wanted to shoot nitrous to it, and I did not. But you know, it's not as fussy as some guys think. You know, that the end gap on the ring's better too loose than too tight again. You know, you don't want them too tight or you're going to have problems. But I think these are like 40 thou. They got quite an end gap. I checked when I put them in the, you put the ring in the cylinder and use a feeler gauge and check it. But it's all kind of cheap, you know, Eagle H-beam rods. These Icon pistons, I can't remember who they're made by, SRP or somebody. They're nothing, none of it's anything fancy. But we're gonna put one in here. I got one in the whole ring compressor on it. You know, I use this, squirt a little, just some 2050 motor oil on the scraper ring and the ring gaps, and lubricate the cylinders a little bit with some regular motor oil, and you put the ring compressor on. I've already got it, you know, I didn't show you the ring, putting the rings on the pistons and all that. It's just basic stuff. Can't really think of anything. With the floating pins and spiral locks, those spiral locks are kind of a pain in the ass to put in, but I like them better than the circlips. I think they're safer, you know. Like I say, we're not building a NASCAR engine here or anything. It's just gotta, you know, run about 6,000-7,000 RPMs, and that'll be plenty. But I'll knock this one in the hole. The main thing when you put these in is don't let it go down and nick the journal. So you want the crank turned. We'll do these one journal at a time, and you turn the journal so it's far away, you know, so it's way down, it's down low, and then you put your hand up underneath there and hold the rod as you knock it in there. And I just use a wooden hammer handle, and if there's any binding at all, if something wrong, it should just kind of snugly slide down until you're close to the journal, and then you do it by hand from there. Piece of cake. Oh, and you should clock your rings. You know, they move around anyway when the engine's running, but I usually clock it so it's on the top side, kind of at 10 and 2, you know, your compression rings. And then I make sure that the scraper rings are not all in line with each other, the gaps. Clock those about the same and make sure nothing's over. These have quite a high pin height. So you make sure that the gaps on the rings are not over the pins themselves. Just, you know, like I say, everything moves around probably when it's running anyway, but just a good way to start out. When you put your rods on your pistons, you have to have this chamfer on the outside. There's a fillet on the crank where the journal meets the counterweight. And these need to be out. The flat side, you can see the difference here. The one without the chamfer needs to be mated to the other rod, in. Chamfer out, or she'll puke. And then, of course, valve reliefs go up. So all the rods go in the pistons pretty much the same way because you're flopping them when you go to the other side. But pay attention to the with the rod itself or you're going to get in trouble there. So you see, here is the chamfer, and this is what's called the fillet. So you can't really go wrong. And you can't really get your caps on backwards either, because your cap has that same chamfer, and those go, this one over here is on that side. I didn't really mean to turn this into a instructional video on how to build a big block Chevy, but it's kind of turning into one, huh? I'll quit filming so much. Now we're going to do the same thing with the rod bearings as we did with the mains with the plastic gauge. Same deal, no lube, put them together dry, make sure that each cap is mated to each rod. You cannot interchange caps and rods. And then you put your bearings in there dry, and you'll see on these bearings too, the bearings have a chamfer that fits this fillet just like the rods do. So you have to have the chamfer on the outsides on the bearings and the rods. Then we'll put the caps on, the right cap on the right rod, and we'll do one journal at a time, and we'll check this bearing clearance. Like I say, there's no reason that I shouldn't be able to trust it, but this is offshore stuff, these rods. It's Eagle stuff, and I'm not used to using that. I usually, you know, my other engine has Oliver rods. I think that's American. It comes from Ohio or Michigan or somewhere. And I usually use like a Cali's Magnum or some kind of American crank too. So this is all kind of a budget, you know, budget stuff that I just feel better knowing what the clearances are. You know, if anything's off, it's all got to go back to the machine shop anyway. But it just makes me feel better putting it together and knowing where I'm at on all the bearing clearances. Okay, got the plastic gauge on there. We got a lot of glare going on here. Let's see if I can get a better. Anyway, we're going to do the same thing. We're going to measure that. It looks to me like we've got about 2/1000 clearance, which is pretty standard on these. You know, everything's brand new. I don't know why it would be off, but I like to set them up a little looser than that. I like to see 3/1000s, and then I run 2050 oil, which I probably will anyway, but on a high RPM application, the theory is you want oil in, oil out, because oil is what keeps the bearings cool. And everything's riding on that oil. And when that oil gets too hot is when you spin the bearing. So the more clearance you have, the more oil you have in there. And that's the theory, is you got a lot of oil circulating through the bearings, they'll run cooler on a race application. So I like mine a little loose, but this will have to do. I mean, it's just offshore stuff. But now repeat that process for all the rest of the rods. Assembly. Try to show you. These are those ARP 2000 bolts. I wouldn't put together any engine without those. Never skimp on your rod bolts. I think the bolts break before the rods. And big block Chevy, it's always lifters and valve springs. I mean, your valve train is, you can't buy too good of a lifter or a valve spring. But anyway, we'll cover that later. Repeat for the rest of the rods, and then we will handle next step, the cam. Plastic gauge is cleaned off from the journal, and the crank has been cleaned with a lint-free cloth. assembly lube applied, and the cap's put back on, and now everything gets torqued 75, 80 pounds. Go over them like 3 times. Make sure. ARP sends that Ollie lube. Make sure and use that like they want you to. Torque it to their specs. I guess I should also say that torquing isn't really the ideal way to put on rod caps and rod bolts. A bolt stretch gauge is what the pros use, but on a street strip application like this, torquing's just fine in my opinion. But like I say, we're not building a frickin' pro stock engine here or anything. Okay, rotating assembly is all in. Still waiting on the cam, so we're gonna put the oiling system together here quick. Put the stud in for the oil pump and prime it, and put the filter adapter on. A lot of guys like to get rid of this bypass. What that does is it bypasses the filter if the filter gets plugged. But again, you know what I mean. It's just, this is just a street engine, and some oil's better than dirty oil's better than no oil. I don't know. We're just putting it together. Little thread locker on the bolts, and then this goes on here like that. You can put the little thread locker on the bolts. There's no gasket at all. It's just metal on metal. Same thing with the oil pump. You don't want to use any sealant or gaskets, because if any of that ever went bad on you, or got into your oil galleries, it'd blow up the engine. What we're going to do is, this is where the only provision for the oil pump gauge. It's huge on this. We're going to have to reduce down. And then there should be a plug in this one. And this one's just for your, if you have a manual tranny, that's your clutch linkage. But you want to make sure that all these gallery plugs are in place, and the engine drain plugs all have thread locker on them. You know, they take all those out, hopefully, at the machine shop when they cooked it in the hot tank for the block to clean the galleries. And then you want to make sure that all those plugs are back in and have thread sealant on them. Just a nice liberal amount, you know. You don't want a bunch of thread sealant getting in your oil galleries either. You don't want anything in there but oil. But now we'll torque these to 35, and then we'll put in the oil pump stud, and I think that gets torqued to 65, 70. And you got to prime the oil pump before you put it on, and then we'll prime the whole system. I'll show you how to do that when we get it all together. Pump and prime the whole system. This is kind of an old tried and true pump that we used to use back in the old days. It's Melling. I think it's a M77 HV they call it. I always use a high volume pump with high performance engines. This is old school, and I heard that, well, on my other engine when I was building that, we don't use a 77 HV anymore. We use a 77 HV. It's called a Melling Select, because I guess these are made offshore now, like so many high performance parts are. And the regular M77 just has cast iron gears in it now, I guess. where the milling select pumps have steel gears. So this, again, this is a budget build. We got a lot of offshore parts going on this engine. So this is regular old school M77 HV, and then we'll pour a little oil in here, rotate it, kind of get it lubed up and primed, and then we'll prime, make sure and fill all the oil galleries and everything. When we get everything together, we'll prime the whole engine block. Stock pickup on here, we put a little bead of weld on here to keep it, because it's just a pressed in fit on the stockers, but I don't like that, and they make new ones that go to this bolt, so they're actually held in place with a bolt, but they like to crack too under high RPMs, but they're better than the old weld up jobs. But I'll show you that when we get to that next step too. Okay, here's what I was talking about with the oil pump pickup. It's not only pressed in, but it also uses this bolt on the bottom of the pump to hold it in place. And then when we get it on the engine, everything is bolted in place. We'll put it on there along with the drive shaft, and then we will have to check to make sure we have enough pan clearance, because there's supposed to be about a 1/4 inch clearance between this pickup and the bottom of the pan. Too much is bad, and too little, too tight to the bottom of the pan too will starve it. So we'll test for that here after I get the pump bolted on. And Molly shaft, American made. I like to use the ARP or a brand name oil pump shaft every time too, because I have seen these ears break off. Happens quite a bit on high RPM, high vibration engines. You stick that in the hole, you can't forget your shaft, and then put your pump up here. Most of the time when you have things like the ears breaking off on your shaft or these bolts, pickup cracking and stuff, most of the time that's, a lot of times, it's from not having a good balancer. And I'll show you that when the time comes too, because I always try to use an ATI, a super damper, because the harmonics will cause a lot of mayhem on a racing engine. And even on street engines, I always like to use a good balancer. I can't stress the importance of a good balancer enough. It keeps... All ERP systems come with a washer. A lot of times, like on these main studs, you got to make sure there's a bevel, and the bevel goes toward the head of the bolt. You got to make sure that's correct. But this is a stud, so it's just a flat washer. And then you torque it down 65. Cam in this thing. Here it is. Unpack it, and we'll get the. This is the timing set. It's nothing fancy. It's regular double roller. I always buy Koi stuff. We'll put the chain in. Just always like to kind of soak that in some 2050 or some 1030 or something, just some motor oil. Let that soak while we're sticking the cam in. Degree it. I don't know if I was recording last time or not, but the cam is already ground at 4 degrees advance, so we should be able to put it in straight up. But we're going to put the degree wheel on it anyway, and then we'll know. You know, there's 3 marks on here that you line up with the mark on the other sprocket, and we should be able to put this in straight up, hopefully. If not, if we need to change like only 1 degree, then we're gonna have to get an offset key or something. Last time I used Quick Adjust, and they don't even make that anymore, but it had screws around here to where you can turn this and adjust it. Hex adjust are junk, but I like the quick adjust, but I guess, you know, this is a budget build, so we're using the cheap stuff. And we'll degree it and make sure we're in the ballpark. If you're retarded on your cam timing, it'll just make a dog out of your engine. So I'm always more apt to make it a little more advanced on the cam timing than if you know, if you're half a degree off, you want to be a half a degree advanced. Give you more zoom down low, because what that does, your cam timing is changes where your power band comes in. And for drag racing anyway, I like it down low. But you certainly don't want to retard your cam. It's just robbing power. Chain's going to stretch enough, and you're going to have enough slop in there to where, you know, the trick system is a belt drive, because then you're right on the money. You know, there's no give. Okay. Lubed it all up. I like to use some of this pretty standard Permatex assembly lube, and you put the sprocket on so you can grab it good, and then you just ever so slightly. No, buddy. Very gentle. Two sprockets. You can see how you need to go in a little bit with the lower sprocket. You just keep going in until they line up perfect. And then we'll take the sprocket back off and put the degree wheel on. That this cam is ground 4 degrees advanced. If you can see this here, the lobe separation is a 108 and the intake lobe center line is 104. So that's a 4 degree difference. That means that the cam's ground 4 degrees advance. So what we're going to do is we're going to, that's what we're going to check, is the intake lobe center line. We're going to make sure that's dead on. And first of all, we're going to find top dead center, true top dead center. We're going to use a piston stop, and I'll rig that up on there, and then put this on there for a piston stop. We'll find true top dead center, and then we'll throw on the degree wheel and we'll check a couple things. But for sure, the intake lobe center line has to be dead on. If it's not, we're going to have to pull off that bottom sprocket, get an offset key, because we have such a cheap timing set that we don't have any adjustment on it. So I'll show you how to set this all up. Checking the orientation between the camshaft and the crankshaft to make sure they're exactly what the cam manufacturer says they are, or maybe a half a degree advanced from it. Alright, so we've got the marks lined up, round mark, so that should be straight up. This mark would have been advanced. You know, we would use these different keyways to advance or retard it, but we're going to check it like this. It's supposed to be straight up. So we'll throw the degree, rotating it, and you just use a breaker bar. Tighten this with an Allen wrench. We got our handy dandy cranker thing here. We got a pointer on here. And you just loosen up this knurled part. And you throw the wheel on. And now we're going to bend this point. And the LS6, I'm going to guess when I first put it on, depending on how long that piston stop is down in the hole, you know, you got 10, 20 degrees. I'm just going to guess 20 for now. And I'll show you here. We got our wheel on, got our piston stop in place, got our pointer lined up nice, and we're ready to turn it over in each direction. And you just want to equal, you know. We'll turn it clockwise and see where it stops, and then we'll turn it counterclockwise, and we want those two numbers to be exactly the same, and then we'll know that our piston is at true top dead center. This piston stop, you want to have it as close to dead center in the middle of the piston as possible, because the pistons do rock in there a few thousandths. So if you're off to the edge, you're not going to get an accurate portrayal of where that thing is stopping. Okay. So I can tighten our piston stop a little bit here. Okay. It's hitting there at about 18 and a half. And I'm going to go around. Oh, that didn't work. Cut. Okay. We're at 28 and a half. Before we go back. You don't want to slam it. Now we're at 28 and a half after. So now we're at exactly 0 when we take the piston stop off. 28 one way, 28 the other way means with no piston stop, we'll be dead on 0. You want to make sure everything is really good and tight once you get that set. And then you want to make sure not to bump your pointer the whole time when you're doing this process, or you'll have to start over and find center. And the reason we do it like that is because when the piston's at the top of the stroke, there's a period where it dwells at the top of the stroke because of the roundness of the journal, you know, being at the top of the swing. And if it dwells up there for a couple, 2-3 degrees, and you don't have it dead on, true top dead center, I mean, you can get a degree or two off on this, and it makes all the difference in the world. You can make that 1 degree or 2 degrees on your cam timing can make the difference between a crisp and snappy engine and a total dog. So true top dead center is super important. And I also like to put my timing pointer on at true top dead center, because you get these guys, you know, they say, oh, my car likes a couple extra degrees of timing or whatever. Well, their pointer probably isn't at true top dead center, you know. it's an important thing. It's the difference between this handy dandy tool here. This is a Lobe Checker. I mean, all you need really is a dial indicator on a lifter, but you'd have to use a solid lifter and kind of a magnetic apparatus. So instead I just have this this Lobe Checker here that goes in the intake, because what we're going to be checking is intake lobe center line. Make sure it's dead on. That's the most important, easiest way to degree a cam, I think. Everyone's got their own way of doing it, but what we're going to do is make sure that the intake lobe center line is exactly 104 degrees. And that's how I know that this cam is ground 4 degrees advance, because it's got a 108 lobe separation and a 104 center line. So that 4 degree difference is an advance to start with. So that allows us to put the timing set on straight up. And if it's off when we check this, we're going to have to get some kind of a different timing set with more keyways or an offset key or something, but hopefully we'll be in the ballpark here. And we'll give her a little check here. We'll check lift, and we'll check duration, and we can, but the main thing we're after is that intake lobe center line, and make sure it's exactly what the card reads. That means we've got it in there right in relation to the crank. Okay, we've got our Lobe Checker all set up. I don't know if you can see it or not, but we're in there on the base circle of the cam, which is the flat non-lobe part of the cam, and we've got it zeroed. So now we're simply going to check the lift. We're going to turn it over until, I'm going to count the rotations. We should measure out at 430. That's the gross lift on the cam. So we'll do that quick and get to maximum lift. The dial should go around 4 times and then stop at 30. Careful not to bump the pointer. I'm going to go around here until we hit the lobe. You can see it coming up. Maybe you need a better view here. Okay. Alright, there she goes. Starting to lift, it goes around once, back to 0 twice, back to 0 3 times, back to 0. There's 400. Now it should go up and stop right at 30. And start going back down. We're at 30. We were at 31, and now it's starting to go back down. So there we are. We'll stop it at maximum lift. All right, let's degree this thing in. We're at the very top of the cam lobe. We're at maximum lift, and we've zeroed out the dial indicator. Now we're going to turn the crankshaft clockwise until the dial indicator reads 50 thousandths. You always want to do everything clockwise because of the slack in the timing chain. You want to take the slack out. So if you go past 50, you got to back up. You want to take your reading always. Your final move should be going clockwise. It may take a few tries to stop right on 50. There we go. And now you can see our reading is 155. Write that down. Crankshaft, the degree wheel reads 155. So We got that written down. Now we're going to turn it counterclockwise. We go back to the top of the lobe, 0 on the dial indicator. Now we're going to go past and go down 50 thousandths again. And remember, we need to take that reading going clockwise to take the slack out of the chain. So we go past 50, we go back, we stop right at 50. Look at that, man. I hit her on the first try. Now, we take that reading. That reading is 54, it looks like. So then we write down 54 over here. Okay, 54. What we come out, we add those two together. We got 9, we got 0, we got 2. And then you divide that by 2 to get your intake lobe center line, which is, what would that be? 4.5, right? 104.5 plus 104.5 is 2.9. So we're a half a degree off, which is the acceptable range on this. You know what I mean? That could be in my measuring equipment or a little slop in my keyway on my thingamajiggy there, that tool right there. You know, a half a degree is not going to make or break anybody. You know, if it was a full degree or 2 degrees, for sure, we'd have to do something. But the card says intake lobe center line, 104 degrees. We're at 104.5 when we checked it. And our lift is actually, it says it should be 430 gross, and we're at about 431. So, you know, we're in the ballpark here. The cam is what they say it is. The card says it is. And in relation to the crankshaft, we're pretty much right on the nuts. So this thing's ready to run, man. You know, what we did there was the same thing we did with the piston stop. We went 50 before and 50 after to get the true top dead center of that lobe on the cam. And our reading was 104.5, but 104, close enough. Okay, we got the cam all agreed, and now we are going to install this little cam button with roller cam. You don't have a way to keep the cam from locking, so we're going to put this, take those bolts out, and put this cam button on there, and then we will measure how much cam lock we have. There's different lengths of these cam buttons, different styles too. I like to just use a solid aluminum one if I'm using an aluminum cover, because that determines the length of it too. So we'll throw this on there, and then we will measure the end play on the camshaft. And then it's got some little tabs on this that you bend over. It locks the bolts in place, but I usually don't bend those over until I put the cover on and check the cam lock. Should be about 10 thousandths, and then if it's good, then I'll take the cover back off, bend over the tabs, put the cover back on one final time. And these, all the cam button does is ride on this, on the cover. Cam button rides against this. And you might as well throw the seal, front seal, in the cover, and you have to have your gasket on. Okay, Looks like we got everything about right. Here's how you check the end plate on the cam. Actually, you should really use a dial indicator on the end of it, but for now, for this build, see that little bit of movement? Be very careful not to scratch your lobes. I don't think you can even see it on camera, but I can feel it in the screwdriver. Ideally, you want about 10/1000ths of play. Okay, time to throw the balancer on. I like to use an ATI super damper. Can't stress the importance of a good balancer. And then you have this tool to put it on there with. So I don't like to use, some guys just use the bolt to put that on, and that is a bad idea. First of all, you gotta use this adapter. Okay, balancer's all on. Now we can take this tool off from here and throw on the bolt, and then we'll put the pointer on. I've had this rigged up here with a piston stop to kind of a rinky-dink setup, but that kept it from moving off from true top dead center while I tighten that on there. Now we'll put the pointer on and it'll be completely accurate to true. Like it's going to fall off or anything. Put on the pointer. Kind of had to modify this pointer because we have a 7-inch balancer now instead of an 8, but it should be just fine. And then we'll put a nice mark on there so we're at true top dead center and bolt her up. Okay, we got that all on there and lined up nice. Ground a little slot in it, painted it white on the pointer, and it looks pretty factory still. You know, that was the deal with the cover too. You know, they make all kinds of nice timing covers, but what we're trying to do here is be stealthy. That's why I painted the ATI balancer orange too, just for the fun of it, because we're trying to make this look as bone stock as possible and make as much power as possible with the correct numbers. I should tell you what we're building here. This is, you can see it's a CPX, and that is the serial number that matches that car over there. It's 71 Corvette, LS6 clone, but this is going to be as close to the real motor as the real deal as possible. I don't know if you can see that, but we got a 512 engine block, which was 69 to 71 was the last year, and it is dated. I don't know if you can see that, but 770, and all the engine components and cylinder heads and everything are cast a couple months before the car was born or comes off the line. And the car has a date of 171, so we have a 770 and the 512. Everything is matching here. Date code correct. Cylinder heads are date code correct. 394607, 3964 is anyway. The correct heads that would have been on a 71, they're at the machine shop now, getting ported and worked. It'll be all the aluminum parts, like the cylinder heads. That's what's rare about a 71 LS6 compared to a 70. Came with the L88 heads, the 074 heads. So it's a real cool motor. The only problem is they dialed back the compression in 71, but we're going to fix that. We'll have it at 11 to 1. And, or a little better maybe even, I don't know. I want to keep it on pump gas. That's why the small domes. But it'll be a true 71 LS6 motor in a 71 Corvette, and we'll see how much more power. They got shipped to New York, you know, to put the engine together. That's what's unique about a 71 LS6. Everybody talks about the 70 LS6 that came in the Chevelles, but the 71 actually had the L88 heads, a lot better aluminum heads, open chamber. 70 LS6 had closed chamber iron heads, and they made a lot of power, but you can make much more power. The 71 LX6 was much better, but it was only rated at 425, probably put out like 525, but now we'll set the depth on the oil pump pickup, measure the surface. Measure the pan. Looks like it's about exactly an 8-inch. A lot of different pan depths. This one's exactly 8 inches. You want to have between 3/8 and a ½ inch clearance between the bottom of your pickup and the pan. And it's crucial. I mean, if you get that too tight or too far away, the pickup. Because the other one was for an 8 1/4 inch deep pan, and this is an 8-inch deep pan. You know, again, we're running stealth. You know, we're running the stock pan just so it looks stock. And that's the whole build here, is we're trying to make as much power with the stock parts. So, right now we got 7 5/8. About 7 5/8 on a exactly, by the time we crush that gasket, 8-inch deep pan. Now I feel more comfortable with the oil pump pickup having, it shouldn't have less than 3/8 of an inch or you're choking it off. More than a ½ inch, and then it'll suck air. So it's pretty crucial. Got a little sealant in the corners, just because I don't trust this Chinese pan. And take one last look, because we're closing her up. This is your last chance. One last look at the bottom end. And then set the pan on, man. Button her up for what hopefully will be long time to come. At least 300 passes or 10,000 street miles. We'll see. But we got her lubed up. Hopefully we can crank that down. Make it fit. Nothing worse than an oil leaker. I'll give you a good example over here of oil leaker. See those shiny spots right there and right there? Oh yeah. See that rag under? Here's a good example of an oil leaker. Sean will look. We're painting the roof on Sean's Firebird. As soon as I get the... Just gonna throw in an oil filter to keep the crap out of there. Change it right after it comes off the dyno anyway. I like to use these racing filters, good name brand. They've got a check valve inside. Most good filters do have a check valve inside that'll bypass. That's why it's not really necessary to have this bypass, because most quality filters have that. But no use trying to save $5 on a cheap filter and blowing up $10,000. Now that we've got our short block all assembled, it's time to put the top end on. We've got the cylinder heads back from the machine shop finally, and the first step to putting the heads on is we got to mock them up. We're not going to put them on permanently. We're going to put them on there temporarily with a little clay. We're going to measure how close the valves come to the pistons. Piston to valve clearance, pretty important on racing engine. You're usually using a high lift cam with a lot of duration. Exhaust valves usually get you in trouble because on the intake valves, they are chasing the piston down the hole, but on the exhaust valves, they're on a collision course. You know what I mean? The piston's on the way up when the valves open. So that's usually where you run into trouble. But we're going to put a little modeling clay on top of the piston, spray a little WD-40 on the valves, bolt everything together with the head gasket in, torque it down, and roll over the engine, and then take it all back apart, measure what kind of clearance we have with that clay. These are the cylinder heads we just got back from the machine shop. They are a 3946 074 head, correct for the 71 LS6 engine or the 69 L88 engine. There were only about 300 sets of these heads that came from the factory on cars, because there were 188 LS6 454s in 71, and 71 were the only LS6 engines that came with the aluminum heads, and they came with these, and these are dated. See if I can find that here for you. I'll show you that date later. They're dated 1970, so the car is dated January of 71, so these are correct for that car. There are only 188 LS6 Corvettes made, and only in 71, and only 161 L88s made in 69. These are the exact same heads that came on a 69 L88. In 67, 68, they used a closed chamber aluminum head. I think it was an 842 casting number. So these are super rare heads, but they did sell these over the counter all the way through the 70s into the 80s. They were over the counter heads. I'm sure that's what these are, but they happen to have the old 1970 date castings on them, so they're really legit for this car. And what we've done here is some nice porting. We've got the good intake runner. Big Block Chevy has a good intake runner and a hook runner to go around one of the bolts. So this would be the hook runner. It goes around this bolt right here. This is the bad runner, they call it. Usually you don't measure, you know, I mean, you don't brag about the bad runner, but we got the good runner flowing like 375 CFM, cubic feet per minute, and we at 0700. And then we got the bad runner flowing about 10 or